This is the solution to x 0, 2, 0. Okay, so then the main idea for this one is that you need to do algebra steps before calculus steps. Okay, so then, for example, on part A here, the algebra step we need to perform first is that this is x, because this is x to some exponent multiplied by x to some other exponent. That means we need to add these exponents, so 13 plus 26 dx. So this is the antiderivative of that's x to 39 dx, and this is well, we can use the power rule. So this is x to exponent 40 divided by 40 plus a constant. Okay, so then the rule used here, the algebraic rule used here, is that x to exponent m multiplied by x to exponent n is x to exponent m plus n. Here we'll need to do an algebraic simplification. The simplification is that this is the antiderivative of negative 4 y squared over 9 y squared, and then plus 3y over 9 y squared dy. And the algebraic step used here is that we took something that had the pattern a plus b all divided by c, and we wrote it as a over c plus b over c. Then now we need to simplify these as much as possible. So this is antiderivative of negative 4 over 9, because the y squareds cancel. And then 3 over 9, well, that's a third, so plus a third. And then y over y squared can be written as 1 over y. And then this is all dy. Now each one of these can be done independently. So the antiderivative of negative 4 ninths dy is negative 4 over 9 y, and then plus a third. The antiderivative of 1 over y dy is logarithm of absolute value of y, then plus a constant. Finally, these are more or less just 3 different antiderivatives that we just commit to memory. So that 8 just hangs out, and then this is the antiderivative of an exponential. So we will get exactly that exponential back. So antiderivative of exponential 2 to w is 2 to w, and then because 2 is not the natural base, we'll have to divide by the log of 2, minus 2 multiplied by, well, for this one this is just the power rule, so w to 5 over 5, and then plus, that 4 just hangs out because the antiderivative is again homogeneous, and then this will be exponential of 3w, and then divided by 3 plus a constant. So to be clear, this middle one was just the power rule, but for this one, to remind you, what was used there is that the antiderivative of a to w dA is a to w over logarithm of a plus a constant, because, well, in this particular case, a is 2, so like that, and we also have another exponential rule here, and that is that the antiderivative of the exponential of kw dw, where k is again a constant, and so here, of course, in this one we have a is positive, not 1, and constant, and here we have that k is a non-zero constant. In this case, the answer is exponential of kw over k plus a constant.